Thank you everyone for joining. My name is Mark Soro. I'm a technical specialist for Autodesk on the manufacturing side of it. And as you can hear, I'm from Montreal. So not only will this be very interesting from 2D to 3D, but it might be your French immersion as well. So just before we start, I want to start with a poll. So we're going to make this a little bit more active for you. Let me share the poll. I want to know if you are a 2D shop, and please apologize if I'm using the word 2D shops. I want to know if you are a 2D house or a 50-50 house, or you're designing everything in 3D. I'm going to leave the poll open. Just answer if you want to, if you can. If you're listening to us in your car, please stay focused on the road. But if you have time, just answer this, and that will be very interesting. I'm going to share the results in a couple of seconds. All right, looks like we have very interesting. Okay, I'm closing the poll in 3, 2, 1 seconds. So 3, 2, 1 in French. And let me share that. That's very interesting. So mostly 2D, a little bit of 3D, I like that. A little bit, oh wow, 7%, 100% 3D, rock on, love it. So today what we're gonna discuss and talk about is how you can take, let's say, let me hide this so we can go back to my screen. So we can present to you how interesting 2D to 3D might be, and also some interesting stuff for the 3D users out there. So the ends are more important than the means. Absolutely. We need to get products out. We need to work. We need to make sure everything is correct. It needs to move. And it's interesting how many customers are very, very 2D oriented, if not to use the word focus, which is great. Because at the end of the day, it creates products. It is good. It is interesting. We're not taking this away. What is very interesting is how you can leverage what you have. We're not going to take away the 2D part of it. Far from it. There's so many 2D users out there. What I'm going to show you and what the emphasis I'm going to make today is how we can leverage the 2D skills and also work with the 3D crowd. You know, I love this saying. These are the three dimensions, they said. It will be fun, they say. Again, people are a little bit afraid of 3D. There's so many good, incredible, astonishing, for lack of better words, 2D users with their keyboard shortcuts and their auto lifts and whatnot. It is phenomenal. I remember back in the days when I was starting to do demos, I was arguing with people drafting on tables, you know, hand drafting, and it would tell me, you know, I'm, you know, quicker than you are using your 3D thing. Maybe, but if there's some changes, then that's how I can beat you. Apologize for that. So what if we didn't have to choose between 2D and 3D? What if it was a perfect world and we could all work hand in hand? Let me show you some stuff about this. I want to show you how we can associate as seamlessly as possible 2D and 3D. The only mostly two products I'm going to talk about is AutoCAD and Inventor, but because it's always fun to go out of bound, I'm going to take it plus plus. So let's say I'm going to talk about AutoCAD Inventor plus plus. First thing we want to know is, you know, choosing the right tool for the right job. Guess what? Inventor, AutoCAD, Inventor, those are great tools. I want to call them solutions because the workflow is so very interesting. I'm sure most of you on the call, you have a ton of AutoCAD drawings. And maybe some of you have AutoCAD 14 drawings. I say AutoCAD 14 because back in college, that's the first version of AutoCAD I've used. And I think I still have the book about it. Now, let me show you how we can do this. I'm going to use a panel box for this example. And it doesn't matter. It doesn't have to be a car, components, or anything like this. I want to show you how simple it is. I'm taking a DWG drawing coupled with that thing is a step file. I'm going to use the DWG drawing, put it in there. I'm going to, of course, make sure that is oriented the right way. I'm going to remove the layers I don't need. I'm gonna put it exactly on the perfect location, like you can see right here. And this goes a little bit fast, but don't worry, I'm reusing this example a lot. So I'm making sure that I have all the counters that I need. I'm putting some dimension in there, and this is all based on an AutoCAD drawing. Creating an extrusion, I'm moving my view so it looks nice on that extrusion, and guess what? I'm going to keep the result of those two. Now, quickly, you can realize I'm doing a sheet metal part. So why not use a DXF or DWG drawing, turn that into a sheet metal, and then I can use the power of Inventor to add more sketches or more definition to my drawings. So this is one aspect. I'm reusing legacy data one way from 2D to 3D. Look at this. This was very simple. Now it's a sheet metal component. I can turn this into a subassembly. I can create, numbering schemes and whatnot. Very interesting. There you go. Now that everything is positioned as I want to, why not add some weldment symbols? I know that all this can be done in AutoCAD, but look how quickly it can be done here. And look at this. This is what it looks like. It's on my assembly. So it's very interesting. 2D to 3D. Quite simple. Also, what I love and what's very interesting is that I can design in one platform, but I can leverage pretty much everything that we have. Now, the other example that I have, now this is an AutoCAD. This is beautiful black interface, but I'm bringing in an Inventor part. Now, I don't know if you get this, how incredible it is to collaborate with your coworkers. You are a 2D guru? Fine. I love you. You're perfect. Use AutoCAD. This is great. I am maybe a little bit more capable in 3D. So we can both work together. I'm having this great 3D component that I'm designing. You do the 2D drawing of it. This is great. But you're not going to be limited because this is a 3D part. Far from it. You can still use AutoCAD the way you want to. You can still add dimension, add section, move this, move that. This is great. This is collaboration at its best. And this is a funny fact. When I meet customers, this is what I talk about maybe the first second that I introduce myself, how they can collaborate right now with the tools that they have. So let's put in some dimensions. I don't know if you noticed, this is not a section view that was drawn by hand, or I didn't have to do all my elevations and whatnot. I'm simply using the tools that I have in AutoCAD. I'm going to make sure they stack up accordingly, and I'm going to add dimensions. The reason why I'm adding dimensions, and I'm pretty sure you guessed it, is that I'm going to go back in my 3D model and I'm going to change something so you can see the value changing. How interesting is this? So very rapidly, I went to an AutoCAD drawing, imported a 3D part, creating views. I'm back in the beautiful Inventor, no dark interface here. I'm going to simply add or change the dimension to 156. That's it, rebuilding. Guess what's going to happen if I, let's move some more dimension. If I go back in my AutoCAD, you guessed it, you're right, everything will have follow. So look at this, cool part. Let's go back in AutoCAD. Again, back to our interface that we learn and love. And look at this, the dimensions have changed. And this is, again, an instant replay of dimension changing. How interesting is that? Now, so far so good. I hope that you like this. We went from 2D legacy to 3D interesting, but also quite quickly, I went from 3D interesting to 2D awesome. So everyone can collaborate and everyone can work together. But now I'm going to move, let's shift into second gear now. And let's talk, I don't know, maybe electrical schematics. How in the world is it possible to have very interesting 2D schematics into 3D models? Well, all right, I hear you. Let me show it to you. I'm in AutoCAD. I have this great schematic drawing done here. I'm simply going to mix in all the information needed to make sure I talk to Inventor. So we have this great project manager inside of AutoCAD Electrical. I'm going to assign some components. Why not? And I'm going to start tracing. As you can see, we have a great browser of everything that needed. I can search for components that I need. So I'm searching for a Bosch element. So why not put this Bosch component right here, where we can have all the information. And I know for most of you, AutoCAD Electrical is something that you know and work easily with. Some people are still using their own custom blocks, but having electrical in there is having a library of tools and also a connection to something 3D. So let's just connect those wires together like this. Nothing too fancy, nothing too complicated. Pick and choose. I like using this because it's easy to pronounce, even if you're French Canadian. So you pick and choose your components, your connectors, and your wires as well. Then it's as simple as syncing with the 3D model. Now it's going to give you inside of Inventor the components that you need to insert. I have a nice little graphic preview. I can pick that component and I can connect it where I need to connect, like this. Now this is from 2D schematic to 3D viewing. It's great to have your cables, your harnessing, your electrical components inside your Inventor design, because first of all, you can check for collisions, interferences. You can have those great drawings as well, where it gives you all the connectors with the where to. This is very fabulous, if you ask me. You can have your tables, your building materials, your components, everything is in there. But also the weight. If you design your things uh, accordingly, I want to say quote unquote, you can have the weight factor in there. So that could make a difference in shipping. You know exactly how much weight you have on your design. Same thing when I was adding the weld on that little bracket. If I'm shipping, I don't know, 100 of those in one of those crates, what is the actual weight? How many crates can I ship? So having all these great interesting information, being able to validate if the design that I did on my 2D schematic will fit on my 3D assemblies, this is priceless. And also having those drawings that will be very interesting for the people on the shop floor. You know, instead of having pinboards, they can have this and have all the measurements and the values that they need. Now, something else that's very interesting, again, 2D from 3D, is how we can do layout. Now, again, this is just me, but still, since I'm the only one on the line that have an open mic, I'm gonna, call it. I don't like the factory design aspect of it because we can do way more in factories with our layout design tool. The layout could be layout of anything. We have customers doing layouts of of ships. We have customers doing layouts of barns. You can do a layout for much anything. But if you want to have a factory, if you're remodeling a factory, if you bought a factory, if you want to change something, you're getting more machines or something, the factory design layout utilities is very good. Now let me show you. I love this little presentation because it gives you a final product. So this is my factory, and as you can see, I can view it inside of Navisworks. So, you know, it's 3D model. But how we got to this 3D model is quite simple. This is how they build ATVs. So it's an assembly line with the ATVs. We can start the process analysis to start building how this new line will be done. So you can have, you know, bins to processing machines to transportation, anything. You can go from that process analysis and have a 2D projection of it. Then you use that 2D aspect of it inside of AutoCAD that everybody knows and love, and you can start adding conveyors to it. And those conveyors will connect with points. So it's pretty simple. Then you sync it. And guess what? You sync it inside of Inventor. You have now your elevation. You can see it 3D. Now, what's great about this is that you can add more assets from factory. And if you sync it back with Inventor, you'll see it. You can now go inside of Navisworks because you can go from AutoCAD to Inventor to Navisworks, and you can Navisworks do your collision test. So all of this started with something 2D. And then we added a little bit of layers or elevation in Inventor. And then we went into Navisworks because let's say you have a point cloud of a building and you want to do a cloud detection. You can do this in Inventor, in Navisworks. Then you go back in Inventor, change your models, you create your drawing. You can also go back in Navisworks. Imagine that. Everything is syncing together. Isn't it awesome? And it all starts with a 2D layout. So if you're good with AutoCAD and you know your way around blocks and dropping blocks and connecting blocks, then you can work with your 3D colleagues and vice versa as well. You can have it in 3D, you can do some changes, sync it with AutoCAD, and your coworkers using AutoCAD can see this and validate or modify things. So this factory layout utilities is just phenomenal. It is not just for factories, but it is greatly used for factories. Now, perfect. We know how we can go from 2D to 3D. We know how we can go from 3D to 2D. Let me show you a little bit something. I love how everything is interconnected. I love how we can have a change somewhere and it's going to change something somewhere else. We saw it with the 2D legacy to 3D. We saw it from 3D to 2D with the drawings. We saw it with electrical and we saw it with factory. Now, let me show you a little bit of something. This is very cool. We have this great drawing and I'm simply going to move this rib. So I'm changing a rib in AutoCAD, nothing fancy. We do this all day, every day. Eyes closed, holidays, birthdays, all cool. If I update my model, guess what? The rib has changed. And if we go to this 3D model, rib is there. I didn't have nothing to do. I can put it in my assembly and I can move it. So this is might look normal to you, might look normal for the untrained eye, but this is very interesting because we went from a 2D AutoCAD always linked with an inventor. If something changes, let's say this component, maybe not the hardest component, might be not the component that everyone focuses about because it's just a suspension, but it is something that is very valuable. Why not have a modification somewhere that will affect the design everywhere? Now, let's go one notch over. I keep changing gears. This is awesome. So we have 2D, we have 3D, we have validation, whether with electrical schematics to layout. But what we like to have and what we see with our customers is how they have 2D to 3D. Most of the time, this is how it's done. But why have 3D? Is there value in there? Well, let me show you one. So inside of Inventor, what I like is that we have Toolpath. I could easily create a toolpath for a component that was designed and maybe that was started in 2D. And then I can do everything that I need. I can simulate cutting this part. Everything is perfect. What is very interesting in there is that if, let's say, I had a change in 2D, I could see it in 3D and I could upload or update my toolpath. Now, this is Inventor. And in Inventor, we use HSM, as I'm sure you've heard about. And everything is in there. Everything is needed. So you go from one interface that a lot of people know, which is AutoCAD, to Inventor. Again, a lot of people, maybe not the same crowd or the same team, but Inventor and AutoCAD are two of the most known products that we have. And you can cut metal inside of Inventor. Everything is in there. So if you integrate 2D to 3D and then 3D to CNC, that there's value. It's there. It's accessible. It's easy to use. It's easy to sit down and look at it and talk about it and maybe leverage the knowledge of the machinist working on that part because it's in there. It's not a third-party tool. It's not a different tool. It's not a different asset. It's the same data. It's the same single source of truth. So I'm going there exactly. If we can spend less time on the design part of it, on the engineering part of it, and give a little bit more time to the manufacturing part of it, that would be very interesting. You know, most of the time, lead time to get material is pretty much the same. Cutting part is pretty much the same. Where we can gain time on a project, is on the design side of it. If we collaborate with the same uh, data sets or the same data, if we don't have to save as and change this, and if we change something, we have to revisit all the other files to make the same changes. That would be awesome. That would be interesting, and that would cut time of design by a lot. And then maybe if there's problem in production, well, the time you save on design, you will be very beneficial that you did, because if there's any problem in production, then you can use that time. Or, you know what, that would be awesome if you can deliver your project or product in advance. Um, One thing also that's very cool is we've seen a lot of AutoCAD user using Lisp, but we have exactly the same thing called iLogic. iLogic is a rule-based definition. We can use rules to change, like in that matter, a conveyor. So instead of going from scratch every time, let's use a conveyor with rules. And if all those things that everybody knows from Excel, we have exactly the same thing. What's cool about our iLogic is that as soon as you start typing in, it gives you tips and tricks of what you could do or what you should be doing. So this is very interesting. We have a library of different rule sets. Again, like Revit works, this is a game changer. You simply, add comments, add dimensions, click dimension, if this, if that, and then it gives you a little interface like this where you can change parameters in there. So true, false, yes, no, and now it opens up engineering and 3D design to the quote unquote non-CAD crowd. You could have, you know what? I'll bring in my parents in here. You could have my mom designing something. And my mom is your typical mom. She doesn't know what I do for a living, but she sure loves to see shiny stuff on the screen. So you could have something like this. You could sit someone in a chair and say, you're going to fill out the information from that little interface that's going to show up, and that's it. So imagine having a call center, or maybe your inside sales team using this to configure products for you. It's rule based. It's great because you can do anything you want with it. You can have price attached to it. You could have maybe send quotes automatically. There's anything that you can do with it. It is very sensational. And also you can push it to quote unquote the cloud, and using Configurator 360, then that opens up a web-based version of this. So again, something very interesting, very graphical. So get more from 3D. If we use 3D, we saw it with the machining part of things. If you want to create Toolpath, it's pretty simple to do so. What's great about that is not only can you create 3D starting from a 2D legacy or even a 2D design from AutoCAD, you can start cutting metals with it, but also you can leverage maybe some simulation. Now, I love simulation because it used to be called FEA, Finite Element Analysis. Very hard to pronounce when your English is not your first language, but also very harsh. You would say FEA and people would just turn around like, nah, don't do this. Like, nah, not using it at all. But as soon as we started calling it simulation, it opened up people. People like, yeah, I do simulation, I do testing, I do build prototypes, and we test the heck out of it in the shop. Well, why not do it at the same time that you're doing your designs? Well, I'm not a PhD in FEA. You don't have to. You could use simulation right now in 3D, obviously, to know if you're using the right material, if you're not over designed by, an X factor, just to know if you're going in the right direction. Using FEA doesn't have to mean that you're a master's degree or you're a PhD. Anyone can use simulation. Anyone can do a static study to see if they're in the right direction or not. If you need to change the type of material you're using, if you need to change the thickness, and there's money out of it, there's value out of it. If you've been doing this, we've been doing this forever. A bracket, we're doing this bracket forever. Well, you know what? In our simulation, we have a shape optimization aspect of it. And shape optimization could say, you know what, you've been doing this bracket forever, but with the safety factor that you're giving me, we could remove material in the middle of that bracket. It would be lightweight. You could ship more. It maybe could cost less to produce. Who knows? So there's value in simulation. Now, the presentation I'm going to show you now, it's a little bit longer than the ones that we saw earlier, because it pretty much uses everything that we saw, but in one uncut portion. So we have this little component that we saw earlier, but let's say we needed to change that. Let's say we wanted to use a better bracket. We maybe have something that was put there just for measurement sakes, but now we're going to use something that one of our coworkers did in 2D. A nice little bracket that was done in AutoCAD. And look at this drawing. This is awesome. So we will remove the layers that we don't need and only keep the layers that we need. Then the first thing we need to do is relocate or locate the portion where they need to be. Because we're using this in a subassembly context, I can place it where my other component is. And from there, I can select the lines or the contours that I need. And look at this. I can now start using 3D features like extrusion. I can connect my extrusion to a dimension that was there as well. So I don't have to enter a dimension at all. I'm just using the drawing. Because if the drawing changes, I want to make sure that those changes are going to be reflected in my 3D. Again, this is all from 2D. I'm not using Sketch at all, unlike this part here. I'm going to add sketches. I'm going to add features. Those are not from the 2D drawing. And this is great because I can modify. I can maybe change the aspect of this 2D drawing because I can see it in 3D. I see that there's some things that need to change because maybe in 2D it's not as easy as to do interference detection or clash detection. But now I can do it in 3D. I can modify this. I can play with this. I can improve the design if I needed to. And everything that I need is there. You see all those little contours? I selected the circle and just did an extrusion out of it. We can always mirror this because it's a 3D model. So all the features that you know from 3D are now available because it's a 3D modeler. Now we're going to go inside and use some components from our library. And I like this because it's easy to pick and choose. I don't have to design that bearing. It is available in the library. So I'm simply just going to add in there. And now I've completed my subassembly, all from a 2D drawing. Again, what's interesting is I can replace the component that was out there by the new one that I just created, like this. Again, in 3D, very hard to do in 2D. We can see if the fit is perfect. We can reposition the little bushings in there if needed. It would be very hard to do in 2D. Maybe it would get lost in the lines, but I can have the perfect fit now. Now, interesting. I have this component. It's moving. I can simulate the movement a little bit. I can see the interaction with the other components, the links that they have in between them. Now it's a car, but it will be exactly the same thing if it was one of your machines that you designed for your customer. It doesn't have to be a automotive component. Far from it. What I'm showing you is the value that you would get from your 3D. Perfect. Now, what we're going to do is we're going to go into the simulation. Now, for those that are aware, our simulation engine is Nastran. We acquired Nastran a few years ago. Nastran is well known, well, mostly because the NAS in Nastran is for NASA. So that was a simulation product that was created for NASA. So it is simple. If I know how it's fixed, if I know where the load is, I can start a static study and I can easily know what the factor of safety that I have and if I have the right material or not. Now, right now, I'm simply putting my constraints and my loads. It's easy. I shouldn't use easy. It's simple. It's quick. I have my mesh. I'm going to have my results. and we will see how it moves. So right now, this is my von Mises stress in megapascal, but I can change everything. So if you need to collaborate with an analyst engineer inside your company, and it's easy to talk the same language. You can start that process because it's in the data set. You save this, that your coworker, she opens it up on her machine and she started a meshing problem and she starts changing some load, and but you're working on the same data, which is great. You want to maybe have a linear static analysis, you can see here we can have nonlinear, we can have pretty much anything. But it's simple. You can have more than one study. You can change the material to see if it's going to behave differently with the same design. So all of these will be pretty much impossible to do in 2D. But because you're leveraging the power of 3D, the value is in there. The value is very in 3D because not only that, you could cut that part right inside of Inventor as well. So you see we have a fatigue analysis right now. You want to know how many cycles you're going to get from that part. And that's very interesting because if you're designing something, maybe you want to have a warranty in there. So if you know this site that you're going to have, I don't know, 5,000 cycles of that part, then you can say, well, this thing is guaranteed for, I don't know, 4 years because we average 1,000 cycle per year. So it's guaranteed for 4 years. And guess what? It works after the 5th year. It's perfect. Customers are happy. But at least you know where you're going. Now, I don't know if you recognize this. This is the same 2D drawings that we had earlier, that if I do a change out of it, then I save this, it's going to reflect on my component. Should ring a bell. There you go. That's the same component that the change was done starting from 2D. We can insert this nice little component in there. We can update all this. We see the linkage is kept. Everything is moving. Everything is perfect. So we went from 2D. We designed this in 3D. We did some analysis out of it, some simulation out of it. And it's the same data set. We didn't change nothing. We didn't save as. And also what's great is there, like when you watch a movie and they say no animals were hurt, not a single part was produced for that prototype. Everything was done inside our tool. So the world is flat and also round. This presentation was not to tell you what to do or how you do it, because 2D is great. AutoCAD is a great solution, but 3D gives you value as well, whether it's machining parts, whether it's simulation. You don't need to build prototypes, or you don't need to build as many prototypes. It is always interesting to see that you get value out of the two. I'm going to finish with this last slide. 3D and 2D are better together, and we see this at our customers. You should try it. I want to say most of you have access to a collection or a suite where you have AutoCAD and Inventor inside of those. See it for yourself. Try it for yourself. We have a great YouTube channel full of videos and how-tos. I'm sure you're working with a partner of ours, a reseller, for lack of better words, that could also help you with those initiatives that you have. But I want you to try it out. It is very interesting. It is very valuable. You're working with the same data set. Everything is interconnected. Everything is synced together. So there's value in there. We have a last poll, but I'm not going to do it right now. I want to make sure that I have enough time to answer questions. That was something that I was not doing right the other webinars. If you heard me before, never had enough time for questions. So I'm going to make sure that I can answer some of your questions. You can always use the chat window inside the webinar, and I'll answer your questions. Melissa,
Great.
have you seen anything come up?
Yeah, actually, we have. As mentioned, go ahead and submit your questions now using your questions section, and we will address them. Okay, the first question here asks, are the LT versions of AutoCAD and Inventor interoperable as well?
Yeah, because it's just a file. It's just a file system. It's not the solution. So I'll push it even further. Um, we have a customer, a big company, working with other CAD. So whatever the other CAD is, and the end result is always a DWG drawing. They don't give 3D drawings. They don't give step files or anything like this. They just give a convert version of their drawings, and they go from there. They simply go from there. They take that DWG and they rebuild the 3D model. And the funny thing is the same company, so it's a different division, not giving them their 3D model, but it works. As long as you have a 2D drawing, it will work. The inter, inter hope the way it's linked together, it should work as well. If you have AutoCAD LT and you are able to do a 2D drawings, when you do a modification in AutoCAD LT, Inventor should be able to see the changes and reflect those changes as well. Even in
Okay.
French, I was not able to pronounce interoperability. I'm sorry.
Interoperability, yeah.
Yeah, thank
Close.
you. Thank you.
Okay, the next question asks, when you bring a drawing from AutoCAD to Inventor, how do you tell Inventor that the material is rubber or metal? What if I wanted to make a gasket for my engine block?
Yeah, that's great. So as soon as you are an inventor, you can change those material. If you go in the feature side of things on the left of inventor, you can change that material. So you don't have to worry. You can change the material also when you do simulation. So let's say by default, I always use aluminum as my default material because it's shiny. But when I do studies, when I do simulation, I will use titanium. Sometimes I will use all kind of different materials. So you can tell it inside the simulation aspect of it, but you can also change it inside of Inventor. So material, it doesn't have to be in your templates. You can always change it afterwards. Good question.
Okay, our next question asks, I like what I've seen and I'm wondering if there's any value anymore for 2D.
Oh yeah, yeah. I enjoyed that you like what you saw. 2D will always be here. 2D is one of the most used products that we have. So AutoCAD is one of the most used product or solutions that we have. There's always going to be value in 2D. We are going in the MBD way, so the model-based definition. It is going to be very interesting um, to try to cut down on the amount of 2D drawings that are print at least, but not every shop floor is equipped with a 2D screen or with a screen where they can see the MBD information. A lot of our customers are using MBD to define the models that they have, but they do produce a drawing afterwards in there. Yeah, absolutely. So 2D will always be there. 2D will always be valuable just to create a patent. When you submit a patent, you need a 2D drawing. So yeah, 2D will always be there. It's always going to be the basis of something. When I started 3D design, I always sketch out a 2D portion of it. So yes, strong is the 2D.
Great. The next question asks, do the 3D solids aspects functions in AutoCAD have any similarity to the tools you showed in Inventor?
Yes. Wow, that is awesome. Great question. Yes, in AutoCAD, the way you build your 3D, first of all, you need to be armed with a lot of patience, and this is great. Um, so what you do in AutoCAD, to do an extrusion and whatnot, this is valuable knowledge that you can reuse instead of Inventor. The only difference is we don't do Boolean operation as much in 3D, in Inventor. So let's say you have an hydraulic cube. Hydraulic cube, you would extrude it inside of an AutoCAD as a big block. And then you would have cylinders in there and you remove cylinders from block. Well, we don't do this in Inventor. Most of the times, if you need to create connections, you will use the tools that we have that provide those standards connection or holes or attachments. But the knowledge that you have in AutoCAD, I want to say 3D, it's transferable to Inventor, absolutely. And you will find it a lot easier and a lot simpler to use in Inventor. Great question.
Next question asks, will Inventor work with Revit?
Oh, wow. Yes. So wow, in Inventor, we do have a feature called BIM Exchange. So BIM Exchange will allow you to save an assembly or a component as a Revit family. And what's great about it is that it's pretty much seamless. So if you are doing any kind of furniture and you want to have a BIM model out of it, you use BIM Exchange. BIM Exchange will allow you to do a shrink wrap to remove information or components that you don't need inside a big Revit model. The name of the game for Revit is lightweight. So because let's say for a hospital, the furniture that you're making will be present maybe 4,000 times. If your models are heavy, then it's gonna not crash the Revit model, but it's gonna slow down things. So you want a model as lightweight as possible. So using shrink wrap will remove features and components so your model is as lightweight as possible. But also, if you're doing, let's say, a chiller needs connection points. You can also add those connection points inside of Inventor and save it as a Revit model. So very great question.
Okay, our next one asks, I work for a German company that draws 2D in scale, not 1:1. I have to
Yeah.
rescale for full size and then convert from millimeters to inches. When I import,
Okay.
do I need to scale up in the block or will it read the scaled block?
So when you rescale and change the units, sounds like my first year of college. Um, Save it as 1:1 and bring it inside of Inventor. You can always play with the scale inside of Inventor, but since you did your 1:1 inside of AutoCAD, I would do this. I would reuse the work that you did inside of AutoCAD if needed. If not, bring it inside of Inventor, and you can always scale it there. But yeah, that's interesting. That's an interesting workflow. That's maybe a step more to make sure that you are leveraging. The units is not a problem. We can always use those units or change units inside of Inventor. But the scaling part of it, you can do it in Inventor or keep doing what you're doing right
Okay, let's take a couple more. If we create our model in AutoCAD Plant 3D, can we convert in AutoCAD Inventor?
Okay, so if you're doing a Plant 3D inside a Plant, which is basically it looks like an add-in for AutoCAD. The way to do this, I would export as a SAT file or even a 3D DWG or something like this, a neutral format. And then you could import it inside of Inventor. But I would go from 3D inside of Plant into as a neutral format and bring it inside of Inventor afterwards. Yeah, or the other way around. You could maybe bring um, a layout from Inventor and bring it inside of AutoCAD as well. So it depends. It depends on how you want to do it. But most of the times, customers are using a neutral format from Plant and bring it inside of Inventor that way. An export.
Okay, and our last question asks, can Inventor do MEP systems?
Yes. Yes, it can. It's always easier to do it as a 2D layout. So that might be a way that I would leverage the factory layout utilities that we have inside of Inventor. The thing that I was showing you for the ATV company. I would do MEP using this if you needed to have a 3D aspect of it, because the docking systems and everything have a lot of radius. So radius is the most complicated or the most resources consuming thing to calculate inside a 3D modeler, and MEP is full of radius. I would maybe tone down or dumb down the model so I could just lay them out really easily and have a 3D view of it. That could be done. Yeah, it's not out of the box, but it's not a terrible workflow. It's not very complicated, but it would take a little bit of work. But yeah, it could be done. Absolutely.